Hello, and welcome back to the Leetcode Grind. This month we're working on binary search. Let's go. All right, so we have the second problem here. It says search insert position. It's very similar to the first one, which was the regular binary search. So I recommend you check that out. Now the only difference here is that we may actually not have an index position, as in our target might not be there, in which case, in the first one, we just returned -1. However, in this case, we return the index position where the number which does not exist would be inserted. So here, this does not include the target of 2, but if it were inserted in order, it would be in index 1. So 3, which is currently occupying index 1, would be shifted backwards, and 2 would belong between 1 and 3 at index 1. Okay, let's do our due diligence and go over the problem. It says given a sorted array of distinct integers and the target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. What we went through here, and you must write algorithm with O of log and runtime complexity, which basically means binary search. Okay. So let's go over this problem here. It is pretty much similar. The only tricky part is whether to return the resulting left pointer, the right pointer, the middle pointer, and that will become more apparent once we run through some examples. Okay, so we have our nums, we do our standard bounds of left and right, and we take the middle, which is you take the indices of the bounds, which is 0 and 3, add it together and divide it in 2, which gives us 1.5, and then we floor it to access the 1. So we have our mid here. And now let's say that our target is in the array. So if our target is in the array, we go through the middle. Our target is currently larger than the number at the middle, so we move our left pointer to the right of our middle, and then we update our middle pointer to what's now between 5 and 6, or in this is 2 and 3, which is 2.5, and we floor it so left and middle share the same index at 2, and our target does match the value that's currently at the middle, and so we return 2 like we do here. Now, what if our target is 2? Well, we did that here, so why don't we say, what if our target is 4? Let's start again. Our left and right pointers are like so, and we say the middle is, once again, 0 plus 3, floor divided in half is 1. Our target is larger than the value in our middle. So we move our left pointer to the right of our current mid pointer, and then the value that between 2 and 3 indexes is 2.5 floored. Once again, we share the index at the left pointer, and it's at this point we'll note that the target is now less. It's now less than the value in the middle. So at this point, when we move right to the left of our current mid, what happens is left and right cross over each other, and then we break the loop of going from the left and right edges and going inwards, trying to find our target value. Now we cross each other without finding our target in the middle. And note where we end up right is where 3 is. And where do we expect the target? target, we expect it to the right of 3. We expect it before 5. So it kind of looks like we're supposed to return L. And if we think about it logically, it makes sense because once again, we're starting from the edges. We're trying to find the number in the middle. Eventually, we'll get to a point where we'll be at a number that is maybe close to, but still less than target. And because it is less than target, we'll cross it. And once that's crossed, it'll cross over the point where this should be, and it'll cross over to a larger number, at which point the right pointer will cross over backwards and it'll break the loop, and the left pointer will be pointing to the position where our target can be inserted. All right, so let's give that a go. We have our left and right pointers initialized to the bounds of the array. So nums -1. It's a similar loop as before. So while left pointer does not cross right, here they cross right and left. They crossed over each other, past each other. We grab the middle point, which is in between the two. So left plus right, floor divided in half. And then we check, you know what, if our target number that we're searching for happens to be at num right in the middle, then we found our index and we return this index, like in this example. Now, if our target, as in if we don't return from here, we're still in the loop, we're still in play, and if our target happens to be less than the number in the middle, then that means our target is less than the number in the middle. Let's say if our target happened to be 2, then we can just ignore everything from the middle number onwards. And we can do that by setting our right bound to be just before the middle. Because we know for a fact the middle number is too large. Then because this is sorted, everything afterwards would also be too large. So we update right to be n-1. Otherwise, it means that the target, the number that we're searching for instance, let's say was 7. Then, if our middle is, well, any one of these, then our target number is to the right of middle. So left will be m+1 in order to exclude everything before the midpoint by setting the new left boundary to one position after the middle. Now, unlike the first problem where we return -1, the only difference here is if we exhaust this loop and we don't find our target, all we do is return the left pointer because that will point to the index where this number, which currently does not exist in this array, where this number can be inserted at that index. Okay, let's give that a go. And let's give that a submit. And there you have it. We have our search insert position, which is our second problem from the study plan, binary search. Thanks so much. Happy coding. See you next time.